Hi everyone. Today we're going to study cumulative distribution function for discrete random variable. The cumulative distribution function, or CDF, of random variable x is defined as capital F of x. This is equal to P of capital X is less than or equal to small x. For all small x, an element of real numbers, which is R. In words, given a discrete random variable x, its cumulative distribution function, or CDF, tells us the probability that capital X be less than or equal to a given value. Example 1. Given the probability distribution below, find the cumulative distribution function, or CDF. For the first row here correspond to variable x, and the values are 1, 2, 3 respectively. And capital P, or probability, for the corresponding values of x are 1/4 when x equals 1, 2/4 when x equals 2, 1/4 when x equals 3. Take note here that the sum of the probabilities equals 1. Now we're going to compute for cumulative distribution function, capital F of x. Let's begin with the first blank here. Our formula is capital F of x equals the P when capital X is less than or equal to x. Let's begin with the capital F of 1. This is equal to P when capital X is less than or equal to 1. And this is equal to the P of 1. In that case, it is equal to 1/4. So this value we will write in here. Next is capital F of 2. This is equal to P when x is less than or equal to 2, which means we're going to compute for P of 1 plus P of 2. Substituting the corresponding values here, we have 1/4 plus 2/4, which is 3/4. This is the value we're going to write in here. Next, the last blank is for the F of 3. This is equal to capital P when capital X is less than or equal to 3, which means this is P of 1 plus P of 2 plus P of 3. So we substitute the corresponding values from the table. We have 1/4 plus 2/4 plus 1/4. And the sum is 4/4, which we can simplify into 1. And this value we're going to write in here. Take note that this capital F of 3 is the last value. And for all the computation, this must always be equal to 1. This is the final answer. Example 2. Given the probability distribution below, solve for A and find the cumulative distribution function, or the CDF. In the first row, here are the values for x, namely 2, 4, 7, and 10. The second row for the probability, we have 0.1 when x is 2, 0.3 when x is 4, 0.4 when x is 7, and value A when x is 10. To solve for A, we take note that the summation or the total of these probabilities equal to 1. So what we're going to do, we're going to add all the probabilities and equate it into 1. So we see here 0.1 plus 0.3 plus 0.4 plus a equals 1. Combining the numerical values on the left side, we have 0.8 plus a equals 1. Solving for a, we will transpose 0.8 on the right side. So we have 1 minus 0.8, and the value of a equals 0.2. We write the value in here. Now we are ready to solve for capital F of x. We will do a quick computation here. For the first blank, we will just copy the 0.1, so it is here. For the second blank here, 0.1 plus 0.3, so the answer is 0.4. For the value here, we're going to add 0.4 plus 0.4. The answer is 0.8. For the last blank, 0.8 plus 0.2, the answer is 1. This is now the final answer. Example 3. Given the cumulative distribution function, find the probability distribution. This time we have a reverse process. The cumulative distribution function is given here. Now it's time to get the probability distribution. For the variable x, the values are 0, 1, 2, and 3 respectively. For the f of x, it is 0.2 when x equals 0. The value is 0.4 when x equals 1. The value is 0.9 when x equals 2. And the value of 1 when x equals 3. Let us now compute for the probability. Let's begin with p of 0. This is equal to that f of 0 itself. So the 0.2 we'll just copy in here. Here we go. Next is the p of 1 that corresponds to this blank. This is equal to this f of 1 minus f of 0, meaning this 0.4 minus the preceding 0.2, and the difference is 0.2. So this answer we will write in here. For the p of 2, we're going to have this f of 2 minus f of 1, or we say that this 0.9 minus the preceding value 0.4. So we write it here, and the difference is 0.5. We will list it here. The last is for p of 3. The formula is this f of 3 minus the f of 2, meaning this f of x value minus the preceding f of x value. So that is 1 minus 0.9. And the difference is 0.1, and this answer we will write in here. Take note that the sum of all these probabilities is equal to 1. This is now the final answer. I hope you learned something from this video. See you again next time.